Welcome to Exploring Axon, a podcast where we discuss Axon Framework, Axon Server, and their ecosystem. I am your host and the producer of this podcast, Sarah Torrey. Happy New Year, everyone, and welcome to the 6th season of Exploring Axon. We will kickstart this season by talking about attribute-based access control. In the next 2 episodes, you will be listening to a conversation I had with Dominic Heutelbeck on attribute-based access control. Dominic is a computer science professor who is leading the FTK Research Institute in Germany. In the first portion of our conversation, Dominic explained what access control is and the importance of it. He also explained what attribute-based access control is and why would one want to use this. He talked about policies, differences between traditional ABAC and existing standards such as XACML, and much more. In the second portion of our talk, Dominic will explain how ABAC can be used to secure Axon-based applications. I hope you enjoy this talk, and let's have a listen. Hi, Dominic. How are you today? Thank you so much for joining me.
Hello, Sarah. Thank you very much for having me. So I'm doing very nice, and I'm looking forward to our conversation.
Same. I had the pleasure of meeting you in person actually last month, which was wonderful. Usually, I don't get to see my guests in person for a while, or if ever. So it was a really great opportunity to get to meet you and listen to your presentation that you did for us at our conference in Amsterdam. And after the conference, you and I had a brief conversation about, hey, let's do this in a podcast. It would be really great to have this topic that is a complex topic. There's a lot going on, but we said, why not? Let's do it in the audio format and see how it goes. But before we get into the great topic of attribute-based access control, let's talk a little bit about you. Where are you located, and what do you do? Can you tell me a little bit about your background?
Yeah, thank you very much for the introduction. I also really enjoyed meeting a lot of like-minded people at the conference. So, yeah, my name is Dominic Heutelbeck. I'm a computer science professor from Germany. I'm running a small research institute, which is associated with the University of Hagen, which is the largest distance education university in Germany. But my main occupation is running the institute, doing research and development projects, doing technology transfer, and also doing professional Axon consultation on the side.
Awesome. Fantastic. So I'll get to why Axon here in a bit, but as Allard mentioned also at our conference, a lot of times when you hear research professors, especially, or folks who are spending a lot of time doing research, many times we have this sort of presumption that everything's going to be extremely abstract and not really practical. But in this talk that you mentioned and the examples that you talked about, which we'll get into here in a few minutes, there's a lot of practicality to it. There is a lot of practical usage that happens with this research and with what you've done with the Institute, which I'm really excited to be talking about and to hearing some of the examples as we go on and see why this is not just abstract and why there's a lot of practicality to it as well. So can you tell us a little bit about what is access control? Why should we care?
Okay. I think access control is something that's pretty much mandatory in any serious software development right now, because we have to be compliant with a lot of requirements that may come from laws or from contracts, or with regards to standardization. So, for example, you have to be compliant with GDPR. When working in an engineering environment, you're not necessarily dealing with sensitive information of the personal nature, but you often have sensitive nature with regards to your intellectual property. You want to protect when you're working in a complex cross-organizational setting where you have to collaborate on problems mediated by some software. And of course, if you're then moving to domains like e-health, then you have a lot of personal information that is extremely sensitive and has to be taken care of.
Right.
So it's on the one hand really complying with these kinds of access to data, like access control, but this goes a little bit further than just I want to read something. It's also what are you allowed to do with it in general? What kind
Right.
of modification and what kind of side effects do you have to trigger? And access control is basically just the step of is this person or system allowed to do this action with this kind of resource and under which kind of conditions. So
I
that would
see.
be a very colloquial way of expressing it, which is also formalized in many models.
Yeah, exactly. Thank you for that really great explanation. So we dealing with a lot of what is authorized basically to do, and can we talk a little bit about authorization and what that is in this domain, basically?
So first, you have to be careful to differentiate authorization from authentication, because
Right.
authorization always happens after authentication. So first, you have to find out uh, what's the system or who's the user that's interacting with the system. That would
Right.
be then the authentication. So then, in some kind of session, usually you would have an identity assigned to the party, to the entity that's interacting here. In access control, we usually call this entity the so-called subject.
Hmm.
And then, after authenticating the subject, you have some code paths where your requirements really state, yeah, here you have to be careful who is doing this, who is actually allowed to do this. And when this happens, you may want to enforce some additional requirements like log the access for later auditing. So, in
Hmm.
this code path, um, that has to be identified in the development process. And there you have to establish the access control mechanism, which takes some kind of information from the system context and the identity of the subject, and then makes a decision if you're allowed to proceed or if you get an error back that you are not permitted to do so.
Gotcha. And so with all of this, it sounds already pretty complex and very detailed in terms of what you can and cannot do and can check and so on. Let's talk about attribute based. So, what is attribute based access control then? And why are we talking about attributes here in this sense?
Yeah, we have a relatively long history of different access control models, going
Right.
back to mandatory access control, role-based access models, and so on. And in the last, let's say, almost 20 years now, there has been the notion of attribute-based access control, which
Hmm.
is a more general model that usually is said to be a superset of all the other established models. And what it means is to say, okay, we have this subject. Like I said, we have the subject that is trying to perform some action with some resource in a certain environment. So, but let's stick to subject action resource. And usually you would formulate an authorization question in the form, does this subject have the permission to execute this action on that resource? And then you have to somehow define rules that determine what the outcome of this decision would be. So you have the so-called policy enforcement point. This is the code path we have been talking about before in your application where this decision has to be made. That formulates this authorization question to a different service. So it's delegated to a dedicated service, which would be usually the policy decision point, which then takes a look at this question. And this question is formulated in a way that there are attributes attached to the different parts of the question. So the subject has an attribute like username. Is the account currently logged or not? If you have a subject that's using JSON Web Tokens, for example, you may have claims with scopes included in the subject data. Then you have the action. Let's say in terms of action, that would be a command that has to be executed. You would have the command name and command parameters. And you would have a resource that could be an aggregate in action terms, for example, that would have an aggregate type and an aggregate ID and maybe some state of the aggregate. And then based on these properties of these three entities, subject, action, resource, there are some rules that are evaluated and a decision is made. That's sounding a little bit abstract. Usually there is some kind of dedicated language which you would use to express these rules. And there's a rule engine behind the PDP that then uses these rules to make the decision. And there are some additional features like the rules may refer to outside attributes as well. So in addition to the attributes contained in the authorization question, you may ask external sources for additional attributes you need at runtime to make the decision. Like, for example, what's the current time?
Gotcha. Yeah, exactly. And these external sources is what you were referring to as environmental conditions, or are they something different?
Not necessarily. So there are environmental conditions like the current time, or what kind of system deployment do we have? What were the contexts in which the execution happens? But these external sources may also be related to the subject, for example. In our access models, we, for example, can use location data. You could have a location tracker with GPS information and perform something like geofencing, where you only may access a certain entity if you're in a polygon on a map, which would reside then in a geo-information system. And this geofence could be assigned to the resource. So you would load the geofence of the resource from a geo-information system and have a current location as an attribute to the subject. So this can be arbitrary depending on the domain, and they can be dynamic.
So then basically in attribute-based access control mechanism, there are two things, as you mentioned, that are important, which are the policy decision point and policy enforcement points, which you mentioned right now and explained about really greatly. So you did talk about role-based approaches as well. So why would we use the attribute-based access control versus this kind of role-based approaches?
And there are several points. Of course, if your domain is fine with just a role model, which usually means that you have, in our terminology, an attribute of a role assigned to a subject, then these roles have some permissions assigned to them in the system, and that works, and you do not need anything more. And these policies usually don't change a lot, and you only have a small system, then this, of course, works fine. And it's easy to verify and very performant to evaluate these rules. So these kinds of systems, however, quickly get to their limit if you're trying to express more complex access control semantics, like I mentioned, for example, with the geofencing, with time-based things, and suddenly you end up with a hybrid approach where you have roles assigned to the users, and at the same time, in your domain code, you still have to put some logic dealing with these site constraints, and you're mixing up these conditions in different parts of your system. So it's compartmentalization, separation of concerns thing. At the same time, if the entirety of the systems you have in your organization is growing, you may end up in a situation that's called role explosion. So because
That sounds
these
terrible.
requirements,
Yeah.
yeah.
What is that?
So it means that in some cases you end up with more roles than users in your LDAP directory. So just
Gotcha.
because you need to assign all kinds of permutations of permissions to different roles of different systems, and this is not really easily manageable. So you may have 50 roles for 20 users to express that, and this is really the way you model this is far away from how your stakeholders would talk and speak to each other in expressing the requirements. It's a very technical, I think, pretty hacky way of solving the problem. Also, if you look, for example, at a Spring Boot application, you have these annotations that express, has permission when the user has this or that role, and this is in the code base, hard-coded. And if you're trying to change the access control rules in this kind of mechanism implementation, you have to completely go back to the development cycle and your deployment and testing and staging phases to apply a simple change to an access policy when onboarding, for example, a new partner.
Gotcha. So a question, might be a silly question, but anyhow, a question. Would then what you mentioned as subject is synonymous to a role, or can one subject have various roles, or am I completely getting this wrong?
Usually I do not like to talk a lot about roles because the terminology role has this very specific meaning with role-based access control.
Gotcha.
But of course, you're right that usually colloquially the stakeholders will talk about roles in the domain. And if we're talking about that, that's just an attribute that the subject has. So for example, if we're talking about a medical scenario, we would have a member of the IT team. We may have a nurse and we may have a doctor, which are positions or roles in the domain language.
Yes.
But not necessarily roles in the sense of role-based access control. But still, you can express everything you could do in role-based access control with ABAC as well.
Gotcha. Talk about ubiquitous language confusion here. Yes.
Exactly. Definitely. That's exactly what that is.
That's why, it's important. Now, so we did talk about this. Let's talk a little bit about the pros of using attribute-based access control. So you had mentioned in your talk about it being expressive, dynamic, and organizational. Can you kind of walk me through each of those and tell me a little bit about why there are some of the pros?
Yeah, let's start with the part about expressiveness. Like we have seen this role explosion thing with RBAC, you can use attribute-based access control and the policy languages that are used there to express the requirements of the domain regarding access control as close as possible to the domain language without really misusing other access control models. And this kind of RBAC role explosion would be a kind of misuse of that access control model from my point of view.
Right.
Also, if you have a legacy system integrated that is based on RBAC, you can still use that. But you can also do things like mandatory access control lists. You can do fun stuff like Biba or Bell LaPadula models, which would be access control models that are from more the government agency side of things, like top secret access control with clearance levels and so on. And you can that integrate with your specific domain needs. For example, if you're in an engineering domain, you have an external advisor that has to advise you on, for example, the optimization of some mechanical design in your CAD system. They may see some parameters, but they may not see the 3D CAD model because that's encumbered by some intellectual property constraints that your customer does not want to see leaked to some external advisor. And also there are these kinds of things that we can do, especially in our variant of attribute-based access control, which is attribute stream-based access control, where you can do continuous monitoring of access rights. So you can really monitor if the conditions change at runtime and quickly react and push new information as they become available because the preconditions to access control changed, or take them away as the conditions go away for access.
Mm-hmm. Gotcha. Makes sense. And how about it being dynamic?
In the sense of dynamic, I would say it's really if you're using it, it depends a little bit on how you deploy it and how you exactly structure your systems. Dynamic can have two dimensions. On the one hand, the rules may change anytime. So if you say your policy changes under which condition somebody may access something, that is easily expressible by editing and changing the policies, which use their language and are put in a dedicated repository where they are continuously monitored. And at the same time, you have the decisions that can change in real time, which is what's the last thing I mentioned is, let's take, for example, this geofencing location tracking thing. You move out of the region on the map where you're allowed to access a document, then the thing vanishes from your UI. A good example for that are, for example, national libraries where you only get access to documents in the rooms of the library, right?
Mm-hmm. It kind of reminds me of those like little cartoons where it self destroys at the end. It's not there. And
Yeah.
one of the Yeah, exactly. And one of the examples that you had brought up in your talk was about having, for instance, if you're in a medical application, for instance, and you're not supposed to have access to something after a certain point of time, and that button on the UI needs to either gray out or just not appear to somebody who doesn't have access to it, and that you can put a piece of basically either a timeout or a functionality where it makes it impossible for a certain user to access that after a certain period of time, which was a really great example that I have seen in real life. So that was really nice to have that. And one of the things that also you mentioned about the pros of using the attribute-based access control is the organizational part of it, which kind of goes back to the domain part and business side of things. Can you tell me a little bit about that as well?
Yes, for sure. The organizational part is really to have a look at your development process and how your teams are structured. So, for example, you have a team that's primarily assigned to really developing and coding. In the case of X, for example, some domain in Java on the JVM. And you have another team that has a different subdomain that's using an approach developing a subsystem with a small CRUD application with Python and Django, for example.
Mm-hmm.
And they have cross-cutting concerns with regards to the underlying domain model. There's some shared vocabulary, and there are some shared concerns with regards to access control. And this may relate to some business analysts that take, for example, in the medical domain, if you're dealing with a lot of biodata there, you have different customers that have very specific requirements how they consume and configure the output and who may access what from their customers. And those people can then write down these requirements in policies, and they do not have to go back to the developers who are writing the code and change the code and have the complete deployment cycle there triggered, they can do it separately and change this behavior at runtime.
Right.
So this is something dynamic. Also, I wanted to go back to one point of expressiveness, because these kinds of requirements that these people have sometimes say, yes, that subject has permission, but, and there's always the but. And this is something you can usually express in these kind of policy languages, is there are additional constraints that have to be fulfilled upon access. So, for example, yes, because it's an emergency, the doctor may access the patient's data, even though he's not the attending doctor, but please log it and trigger later an audit process.
Mm-hmm.
So
Gotcha.
Trigger some side effects.
Yeah, makes sense. I love how in the business side of things, if you would, there's always a sentence that has that little but in the middle of it. So you can do this but for this thing, which basically means on the engineering side of things, it means a whole new application, a whole new feature. So
Yes.
it's really funny when it's just this little tiny detail here, but it requires a lot more complexity on the engineering side of things, which is great. So you briefly mentioned policies a little bit ago. Can you tell me what are policies and what are they bringing into this whole mix?
Yes, policies are a way of expressing the requirements. So usually when you're going about the requirements engineering of your domain, you would start with capturing these requirements in natural language, writing them down. So you would, and these would already be policies. So usually we call these natural language policies. And these are, with the current technologies that we use, not directly interpretable. There are some research projects that deal with legal text that try to translate that to executable and directly enforceable policies, but that's not where we are at with these practical systems right now. We are at the point where these natural language policy requirements then have to be translated into something that the machine can interpret and base decisions on. And there are, I would say, 3 languages right now that you can readily use. The one would be XACML, XACML, which is a long-standing standard for attribute-based access control, where you would use XML to write these languages. Then there's Alpha, which is stripped down version of XACML with a little user-friendlier syntax. And then there is what we've been developing, which is SAPL, the Streaming Attribute Policy Language. So, and in essence, these are all just documents you write, just like you would write your program code. And then you deploy them to this policy decision point and say, please activate this policy. And then whenever an authorization question comes in, these are evaluated and used for checking for the permissions of the subject.
I hope you enjoyed this portion of my conversation with Dominic. Please join me next time as he will discuss the ABAC in Axon-based applications in more detail. Until then, have a great time and happy coding!